Right. Our main focus is going to be on thermal energy. So this is the kinetic energy that's associated with the random motion of atoms or molecules. So we can have something that's hot, or we can have something that's cold, or anywhere in between. And we want to think about what's going on a molecular level. Well, it's relatively simple. The hot material, the molecules are moving or vibrating around really quickly. Right? If it's a solid, they're doing more vibrations. If it's a gas, they're moving more around. While the cold ones are moving slower. And so then temperature, when we say something is hot or something is cold, it's a measure of this amount of thermal energy, how quickly these particles are vibrating around. And most materials, as they get hotter and they vibrate more, they expand. And that's basically how a thermometer works, right? It's got some kind of material in there that when it's heated, it vibrates faster and then it expands. And then you can, graduate it, you can calibrate it and make a thermometer. So heat technically is a different thing than temperature. So heat gets the symbol Q, and it's actually the transfer of thermal energy. So technically heat is not a thing. It's more of like an action, more a verb. However, it's used as a noun, and I'm going to use it as a noun. But if somebody tells you that semantically, heat is not kind of a noun, it's a verb, they are correct. But we're going to use it in the more common sense version. And so if you notice anything, heat always flows from high thermal energy to low thermal energy until the two things are at the same temperature. So for example, if you had a hot block and a cold block, and you had them touch together, the energy or the heat would flow from the hot object to the cold object until both of them reach thermal equilibrium, and that's that they have the same temperature. Right? It never happens the other way around. You never put a pizza in the oven and then it gets colder, right? You never put something in the fridge and it gets hotter. It always goes towards thermal equilibrium. And remember that energy is conserved. So all the heat lost by one object is gained by the other object. At least in some kind of perfect vacuum. In the real world, we are going to lose heat to surroundings, but when we design our experiments, we insulate things such that we don't lose too much heat.